Another function of operating system is memory management. When you say memory, it is important resource of a computer system that must be properly managed for the overall system performance. In the operating system, we're going to keep track of parts of memory that are in use and not in use. And the operating system will also allocate memory to processes as needed and deallocate when no longer needed. So we have here Uniprogramming memory model. So this model is used in systems that process one job only at a time, and all system resources are available exclusively for the job until it completes. Then this type of memory model is simple and easy to implement. And this model also does not lead to proper utilization of the main memory as an occupied memory space by the currently active user process remains unused. And this model also used only on the very small or dedicated computer systems. So this is the diagram of a uniprogramming memory model. Next, we have multiprogramming memory models. So in multiprogramming system, multiple user processes can reside simultaneously in main memory. And we have two memory management schemes used to facilitate. We have here multiprogramming with fixed number of memory partitions. The second one is multiprogramming with variable number of memory partitions. So when you say multiprogramming with fixed number of memory partitions, user area of the memory is divided into number of fixed size partitions, while the other one, number, size, and locations of the partitions vary dynamically as processes come and go. And we have here a diagram that will show you the multiprogramming with fixed number of memory partition. So when we say partition, the division of the memory. And if we have your multiprogramming with fixed number of memory partition here, so how it will go, if we're going to load process 1, in the first part will be the operating system, it will this area will be added the process 1, and this will be the free space. If process 2 will come in, then it will be stored after process 1, and we have here the free space. And another process will come in, so therefore process 3 will be allocated in this particular part of the memory, and this will become the free area. So this is what we call multiprogramming with fixed number of memory partitions. And this one will show you multiprogramming with variable number of memory partitions. So it will allocate whatever the free spaces available for a particular process, as long as that particular process will fit. Take note of this. If it will not be possible, then it will search for area in the memory where you can place your process. In memory management, we have here a term virtual memory. So let's discuss this term. In a conventional or ordinary memory management scheme, suffer from two main limitations. One, operating system cannot load the process until sufficient free memory for loading the entire process becomes available. And operating system can't load the process if main memory size is less than the total memory required. In order to solve these two problems, there is a virtual memory, which is defined as a memory management scheme that overcomes the limitations of the conventional memory management by allowing execution of a process without the need to load the process in the main memory completely. So this is what we call virtual memory. So how is virtual memory realized? So we have here online secondary storage. So this is a device having much larger capacity than the main memory. There is what we call swapping. So swapping is the process of transferring a block of data from online secondary storage to main memory and vice versa. And we have here Demand paging. So instead of loading an entire process before its execution can start, the operating system uses a swapping algorithm. So when an operating system needs to swap to continue a process's execution, it invokes a page replacement algorithm. So this page replacement algorithm will be discussed deeper in your unit's operating system and machine principles. Okay, so page replacement deals with selecting the page that is residing in memory but not in use currently. Another one about virtual memory. It is often described as the hierarchy of two storage systems. One is low cost, large capacity, low speed system, and other is in high cost, small capacity, but high speed system. So what are the advantages of virtual memory? So first, provides a large virtual memory to programmers in a system having smaller physical memory. The second one, enables execution of a process in a system whose main memory size is less than the total memory required by the process. And another one, enables a process execution to be started even when sufficient free memory for loading the entire process is not available. And the other one, makes programming easier as programmers no longer need to worry about the memory size limitations, and often leads to less input-output activity, resulting in better throughput, turnaround time, and response time. How about disadvantages of virtual memory? First one, difficult to implement because it requires algorithms to support demand paging. Then, if used carelessly, it may substantially decrease performance due to high page fault rates. Next is file management. When you say file, let's define this. It is a collection of related information. Going back to our data are the raw materials, and information are a collection of related data. So if we have a collection of related information, it will become file. So every file has a name, its data, and of course we have attributes or characteristics. File's name uniquely identifies it in the system and is used by its users to access it. And file's data is its contents. When you say file attributes contain information such as date and time of its creation, date and time of last access, we have date and time of last update, its current size, its protection features, and other characteristics. Then when we say file management module of an operating system takes care of file-related activities such as structuring, accessing, naming, sharing, and protection of files. Let's proceed to the file access methods. We have first sequential access method. When we say sequential, operating systems use sequential access files for storage of files on sequential access storage media. So a process can read the bytes or records in the file in the order in which they are stored. But when you say random access files, operating systems use random files for storage files on random access storage media. So applications can access the contents of a random access file randomly, irrespective of the order in which the bytes or records are stored. So we have here different file operations. An example, if you're going to create, so it is used to create new file. If you're going to delete, it is used to erase or delete an existing file that is no longer needed. So open, close, read, write, seek. What is the seek? It is used with random access files. The first position, where is the read-write head or pointer to a specific place in file so that data can be read from or written to that position. Then we have here get attributes, we have set attributes, rename, and copy. File naming is part of file management in an operating system, and we have several rules. We have the maximum number of characters that a file name may have. We have special characters allowed in a file name. distinction between uppercase and lowercase letters. We have multi-part file names allow file extensions to be part of the file name and used by applications to check for the intended type of file before operating on it. So what are the different file extensions we have? Example, .bas, so it means basic source program file. If we have .c, it is a C language source program file, and so on. So if you will see .lib, that is library or of the object file used by the linker, and if you will see .dat, that is data file, and we have many more. Okay, so these are examples of file extensions.